In this video, we're going to talk about factor by difference of squares. So I want to factor completely x squared minus 16. Well, I can rewrite that as a trinomial, x squared plus 0x minus 16. So we've already talked about trinomials. There's no greatest common factor I can take out other than 1. So what do? I can find factors of negative 16 whose sum is 0. So because it's negative, one of the factors has to be positive, the other one has to be negative. Well, in this case, that's going to be what? Negative 4 and positive 4, because negative 4 plus 4 is 0. So I can rewrite this then as x minus 4 and x plus 4. Now, let's go back to x squared minus 16. X times x is x squared, and 4 times 4 is 16. The square root of x squared is x, and the square root of 16 is 4. Notice the factors are exactly the same except one is positive and the other one is negative. So this is the idea of difference of squares. If I give you a binomial, x squared minus y squared, well, that factors down to x minus y times x plus y. Okay, so let's take a look at a couple of these examples then. So we want to factor completely. First thing we want to do, is there a greatest common factor I can take out of both of these terms other than 1? In this case, no. Second question, how many terms? There are 2. Can I take the square root of both terms? Nicely. And the answer to that is yes also. So I'll write the square root of 25x squared is 5x and 5x. The square root of 36y squared, that's 6y and 6y. So this is a difference of 2 squares. So one's negative and the other one is positive. Now, we talked earlier about multiplying to check our answers. So if we write this underneath, because this is a product of a sum and a difference, I only need to take this and this. Because the outer gives me positive 30xy and the inner gets me negative 30xy, which subtract out to be 0. So we factored completely. Okay, let's take a look at the next example. First thing, is there a greatest common factor I can take out of these two terms other than 1? The answer to that is no. There are 2 terms, and I can take the square root of each of these terms very quickly. The square root of 100 is 10. And the square root of y squared is y. One's got to be negative, and the other one's got to be positive, and we're done here. And again, you can check by multiplying, and you will get 100 minus y squared. Notice the first term was 100, so the first terms in each of the binomials was 10, and then the y squared was the second term, and the second term for each binomial was y. Okay, let's go to the next example. First off, is there a greatest common factor I can take out of these terms other than 1? The answer to that is yes. I can factor out or divide out a 9x. 36x cubed divided by 9x, that is 4x squared. 9x divided by 9x, that's not 0, that is 1. Now, let's go inside the parentheses. 2 terms. Can I take the square root of each term? And the answer to that is yes. So rewrite the greatest common factor. The square root of 4x squared is 2x. The square root of 1 is 1. Remember, with a difference of 2 squares, one has to be negative, and the other one has to be positive. So I have completely factored here. Okay, let's go to the next example. Now, first off, is there a greatest common factor I can take out of both of these terms other than 1? The answer to that is no. Secondly, we've got 2 terms. Now, this I could take the square root of both. But the problem is it is positive instead of negative. Does that mean it's still factorable? Well, let's try some things. We know that positive 5 times a positive 5 is a positive 25. We better check this by foiling, right? So that is 5x plus 5x. That's 10x. That's not what we have there. So we know x plus 5 times x plus 5 is not the way to factor it. Now, somebody always tells me, well, Professor King, negative 5 times a negative 5 is 25 also. Well, again, let's check by foiling. Problem is here, we have negative 10x, and we don't have that in the original problem. So I know I can't factor it as x minus 5 times x minus 5. Then somebody will tell me, how about x minus 5 times x plus 5? Well, when we FOIL that out completely, we have x squared minus 25 and x, not x squared plus 25. So it doesn't factor like this. So we've exhausted all our possibilities for this. This is a prime polynomial. There is no such thing as a sum of squares. Okay, one other example I want to take a look at. So first off, is there a greatest common factor I can take out of these two terms other than 1? The answer is no. 2 terms, and I can take the square root of each. So what value times the same exact value gets me to y to the 4th? Well, that's y squared. And I'll do this on the side. Y squared times y squared is the same thing as y to the 2 plus 2 power, which is 4. Square root of 16, that's 4. So one has to be negative, and the other one has to be positive. Now, let's take a look at each of the binomials. Can I factor further? Well, with y squared minus 4, y squared is a perfect square root, and so is 4. Meaning I can break this down again by using difference of squares. So I break down y squared as y times y. Square root of 4 is 2. One's negative, the other one's positive. Now, y squared plus 4. We just finished talking about that there is no such thing as a sum of 2 squares. So that cannot be factored any further, but I need to bring it far down. I have factored this now completely using difference of 2 squares twice.